And we have some people kind of straggling in. If you don't see your friends, send them a text message, tell them about something really cool. So Eric Layton is here. He worked for the U.S. biodiesel project that is not active currently, but he's going to talk a little bit about how that project is going and what it kind of looks like now and how, I guess, it kind of turned into a business prospect for him. And he's been working with us a little bit in the past already. He did a presentation for one of the forecasts that we put together for Power Go. So I want to thank Eric for coming back and working with us and talking to us about biodiesel. And I look forward to
Hello everyone, my name is Eric Layton. I'm a super senior in mechanical engineering. This is my 5th year here. Just finishing up, I decided this past semester that I wanted to stay an extra semester, so I dropped the class I needed, so I'll be taking one class. I absolutely love it here at UF. All of these sustainable projects going on. I look at it from an engineering standpoint. I love building things. I love making things happen. My expertise is solar power, biofuels, and I know this group is against it, but nuclear power. I did nuclear engineering for about 2 years. I earned my operator's permit in nuclear engineering. I learned everything. Our perception kind of changed after I started visiting nuclear power plants, seeing what was going on, doing more research. I switched from nuclear to solar, and then I switched from solar to I have a lot of training in different alternative fuels. I've traveled all over the Southeastern United States. I've visited almost every single biodiesel plant. I need to visit one more in Tennessee, and then I have all, I believe, 27 plants in the Southeast that I've visited, talked with their CEO, plant managers, everything. So I know a lot of biofuels. I'm currently writing a book about biodiesel, so I'm currently doing that. I've been offered grad school here, just the potential to go and get involved with biodiesel reactor that we're currently trying to get at Fred Rogers Hall. I'm thinking about that. I've been offered positions at other schools too, dealing with solar power, solar integration with biofuel systems, that sort of thing. So in this presentation, I'm just going to show you some things that I've done over the last few years. This all started actually in high school in 10th grade. I built an electric vehicle. It's a solar-powered electric vehicle by myself, and it was featured in Fox News, so I can give you that link on YouTube. Anyways, this was a speech that I gave about biodiesel in Tifton, Georgia, at the UF IFAS Conference Center in Georgia. I had a lot of people coming up to me asking me about biodiesel, everything. I had a mini demo where I did make biodiesel in front of everyone. It's really neat. But yeah, that's one of the pictures that I had. All right. Alright, now one of the questions that I get asked a lot of times is why biofuels, alright? A lot of mechanical engineers in the program actually go into petroleum engineering, so I get that question a lot. Why biofuels? So one of the big reasons is that it's economically viable. There's a low cost of production if you do it right, if you have your system engineered properly. Low cost for consumers. So that's the biggest thing I've seen at all biodiesel plants. They have top-notch engineers working, trying to make everything efficient. The best plant I visited was Piedmont Biofuels in, I believe it's Middleborough, North Carolina. It's 10 miles south of UNC Chapel Hill. Beautiful plant, solar thermal panels all over the plant, solar panels. They get a lot of their energy from the sun. They try to use their passive heating in the biodiesel reaction. Beautiful thing, and they're co-op and open source. You can be from anywhere in the private sector, and they'll help you out, so it's great. Environmentally sound biofuels. What's great about biofuels, and especially with biodiesel, there's a lot less NOx emissions. There's less sulfur dioxide emissions. It's also burns a lot better in the engine. So that's one of the big things, big pluses for biodiesel. It burns about 2% more efficient depending on what type of engine you're burning it in, and actually clean all the brine out of your engine. So biodiesel is actually a superior fuel to normal number 2 diesel. You have a question?
Just a comment. Also, to add, another plus is that it's biological sequestration, so it also absorbs carbon dioxide naturally in order to create some of the life cycle balances and move that energy in and out. That's pretty good.
I've seen a lot of LCA life cycle analyses over my time. One of them was for biodiesel, and it's actually pretty good. studying into this, and I've read a lot of books just specifically on this study. If we could take all our fats and oils that are available and try to turn that into biofuels, we could, there's a huge potential up to 5 to 10% of our total diesel supply with our already existing fats and oils in the market, from yellow grease from restaurants to soy, canola oil that's already going to biofuels. If all of that was actually converted to biodiesel, we would need 5 to 10% of our total diesel needs. But that's at the current production right now. Now, if we use other types of plants, like I'll talk about later, a plant called Jatropha that I've been growing a lot of. I'm going to talk about I saw that expression. I'll talk about a company that I actually formed dealing with Jatropha production. And I took that through my experience, and I decided that Jatropha is actually the best biofuel crop. So I'll talk a little bit more about that. So again, it's wide availability. All right, this is a biodiesel, actually. This is the biodiesel reaction. A lot of people heard of biodiesel, but they actually don't know what it is. Biodiesel is actually taking vegetable oil or animal fat. I've never worked with animal fat. None of the plants in the United States work with animal fat. It's all vegetable oil. The number one vegetable oil used is soy. Okay. Number 2 is canola. And then the other vegetable oils I have seen is chicken fat. Actually, never mind. I'll take that back. One plant that is in Dade City, Florida, uses chicken fat. They use very, very, very small amounts when it's available because it can get very expensive, but they mainly use soy oil. They have all the biodiesel plants I've visited have a railroad right next to their plant, and that's where the soy oil comes from. It's kind of a big issue with a lot of LCAs that I've read. A lot of that canola and a lot of that soy comes from the Midwest. It has to be either trucked down or brought down by rail. So it's kind of is it sustainable enough to do that? And what's the big issue?
Huge water quality issues with farming corn and soy in the Midwest.
Yeah, it takes a lot of irrigation.
I took an ecological, ecology class, and they did a comparison, statistical analysis, or just a bar graph on the amount of oil you can take out from a natural prairie land that existed before corn and corn in general. And the natural prairie land, and it's sustainable because it'll grow back, and it'll take it out, you get more biofuel out of that, and natural, easily within some corn, or soy. There are these.
Yeah, absolutely, there are.
Does your cost analysis ever take into consideration government subsidies to corn and soy?
Yes, it does. A lot of the talk, actually, I personally believe that without those government subsidies right now, both with ethanol and biodiesel, the biodiesel industry would collapse, and so would the ethanol industry. The ethanol industry, the only reason it's surviving right now, if you visit a lot of plants and you talk with them, is they get massive amounts of government subsidies because it takes a lot of energy to make cellulosic ethanol. It takes a lot of energy to make biodiesel. So depending on how your plant is configured, it's going to use a lot of energy. But they do get government subsidies. They do get tax breaks. I believe without those tax breaks, it would be possible to produce biodiesel or ethanol at all. So that's actually a very, very good point. So my goal actually is visiting plants like Piedmont, where they're trying to take energy, go off the grid, solar panels, solar thermal panels. The only plant I've ever visited that actually did that, and they're currently still in production. One of the very few plants still in production. Right? So that's actually a good thing.
My question is on where you catalyst, you're doing your reaction with like a flattened, like Layton catalyst that we use.
That's actually a brand new research area that was in Biodiesel magazine last month. Was a platinum catalyst. Currently, what we use is sodium hydroxide or potassium hydroxide as a catalyst. And then there's a couple plants that are experimenting right now with using a platinum catalyst, and that's like the new technology, because that's another point that a lot of people bring up is where that sodium hydroxide is coming from, where that potassium hydroxide is coming from. Make biodiesel with that and it's sustainable.
Oh.
Yeah, did I answer your question?
Yeah, that's great. Yeah.
I'm trying to get to everyone's questions.
I was going to ask you about your consideration for secondary systems for, let's say, algae, chlorella species or something like that, or your consideration on sodium oxide as a catalyst instead of, let's say, ethanol.
It's too bad I only had half an hour. I've attended 3 National Algae Association conferences, and the exact subject has come up many times. I've talked with a lot of professors about that, pretty much read everything I can about that, dealing with algae production. And we can definitely talk about that. I'll talk a little bit about algae in my presentation, but if I had an hour and a half, I'd go on with that.
Positive or,
Which one?
like, what do you see like the project, like, how do you project the algae industry? Like, prospects of algae?
I'll tell you the title of the next biodiesel magazine that's going to come out next month. It's Algae. Is it hype or science fiction? That's actually the title on the front of the magazine. One of the biggest issues I'm seeing in the algae industry is a lot of these big companies are hyping up their numbers, saying a lot of BS to get investment money. I met a guy who claims like 100,000 gallons per acre per year, which is absolutely ridiculous. That is not possible from which I can hear. And so far we've not seen that, and that's the same rhetoric coming out for the last two years that I've been in the biofuel industry. And one of the biggest things is, I won't say company names, but I've investigated a lot, and I think algae has a great potential. Algae can burn anywhere from 4 to 10 times their own weight in carbon dioxide. Great carbon sequestration thing to have algae growing. We just got a grant in Fraser Rogers Hall to take from cement plants. Cement plants are a big source of CO2 pollution. To take algae and actually funnel all the exhaust through the algae. Algae absorbs some of this sulfur dioxide, some of the carbon dioxide, stuff like that. So that's a whole other ballgame. That's a whole other thing. So we got an algae enthusiast back there. But yeah, I think algae is great. I was going to go into that later. I think algae and jatropha are going to be the biggest savings for biodiesel, really. And I'll go over that afterwards. So.
I heard, what about, like, have you experimented with hemp? Hemp as a biofuel?
Yes, I have
It's
made.
quite hard because,
Yeah, it's the perception of hemp too.
Yeah.
It's a big issue.
you can't even grow yourself, to experiment, so you
Yeah,
gotta import it.
that's hard. So what I'm trying to do is figure out what things are available, what things are easy to use, and everything. I've seen biodiesel made from hemp. I've seen biodiesel made from a lot of different plants. But the question is when you do life cycle analysis, how much irrigation is going to take? Stuff like that. Some of these plants are water-hungry plants. They need a lot of attention. It costs a lot. Without subsidies, it wouldn't survive. So that's the big thing with the soy and the canola industry is it's just massive subsidies, just throwing money in, and they're not solving anything. And that's my big issue. So in my presentation, I'll show you later. I got to pay attention to the time. But I'll show you that I believe jatropha and algae are going to be the big things. I think there's still more experimentation that needs to be made, and I'm not going to say it's going to be save everything. Okay, this is actually go along the lines. This is absence of biodiesel in the south. There's actually only one plant still in existence here, and there's one plant in the big city, and that's where the RTS biodiesel comes from. I'm sure you've seen on the side of RTS buses, it says biodiesel on the side. It actually comes from Dade City, which is about 100 to 120 miles south of us. That is usually made with soy and sometimes chicken fat, so I don't correct myself on that. But basically, you can see it's all concentrated here, all biodiesel. It's mainly canola, soy, sunflower, things like that, peanut in this area. So you can see it's heavily concentrated. So one of the big issues is all this biofuel is being trucked, on the rail. I mean, rail is very efficient right now, but still you have to ship it all the way out. So it's heavily concentrated in this area. And this is as of, I believe, 2005. So this needs to definitely be updated. I haven't found any good sources right now that have really updated the plans. I kind of want to do it myself. But this right here is a lot less right now. A lot of the biofuel plants are failing because the price of soy went over $1,000 a metric ton. Same thing happened with canola. So a lot of the plants that I've been visiting over the last year and a half are completely shut down. The workers are doing nothing because the price of the oil is literally 110% of the price of the fuel. They would only break even if they sold their biodiesel for $4, $5 a gallon, because the price of the oil is so ridiculous. So a lot of these plants are currently shut down. So that's a big issue, I think, a big research opportunity in jatropha and algae. This right here, this is fairly accurate. The percentages have actually stayed the same. Europe has gone up significantly, actually. What this does is this shows the percentage of biofuels used in, percentage of agricultural land needed to replace 10% of the transport fuel with biofuel. Now, this kind of just gives you an idea of the specific numbers. This actually comes from Europe, the units are metric right here. What I want all of you to pay attention to is this, okay? This is the best numbers that I can find right here. This is a really good slide. This is the world gasoline consumption in billion liters per year. You can divide that by about 3 to 3.5 and get equivalent gallons. But you can see the world bioethanol production, 36.5 billion liters per year. World biodiesel production is 3.5 billion liters per year. When I go to a lot of conferences and read a lot of scientific papers, everything's in liters. And then when you go to all the plants and everything's in gallons. You know, it's kind of, you gotta do a lot of conversions back and forth. But you can see the world diesel consumption is still gigantic. And even with the world biodiesel production, you're only getting 3.5 million. I've seen studies that you can increase this by 100-fold if you actually conglomerate your sources, start doing research with algae. You know, algae is supposed to be the savior here, and also Jatropha. So this number can increase by a lot, also with the fuel efficient diesel engines being produced. So it's kind of a big research area. I just attended a conference called Farm to Fuel Conference in Orlando. I went to that conference. I met a lot of people dealing with diesel engines, telling me that they're trying to make it more efficient. So with that, I think that's a great thing. I think we got a lot of questions.
The farm fuel?
What was that?
You said you attended the farm fuel?
Oh yeah, I attended it for 2.5 days.
That's what I was at last night when we were doing something.
Oh, really? Okay. Yeah, I met Governor Chris and Charles Bronson, the agricultural commissioner. I got a picture with them. A picture with my business partner, who was part of UF Biodiesel. It was a great conference. I met a lot of people. A lot of people were very hopeful and stuff like that. So it was a good conference.
When you were talking about that it takes so much energy into the production of biofuels, where is that energy coming from?
That energy is coming from, I've read a lot of reports and I've actually seen a lot of these farms, all the soy, I visited quite a few. And what bothers me is they're out there with normal diesel tractors and they can biodiesel tractors, farming the land, maintenance costs, the amount of energy required for taking those seeds, harvesting them, shipping them to the biodiesel plant, and also a lot of water and fertilizer. So there's a big issue with soil runoff, soil contamination, things like that. So that's kind of where I was going to. I think if you look at a lot of life cycle analysis of biodiesel, you'll see different reports and different numbers all over the place depending on whose report you look at. I try to look at universities and try to look at how much water it takes. And so far, all the crops, I think, part of my language, I think mainly all the crops suck, except for Jatropha and apples. So those are the big ones that I've seen that have the most potential energy-wise. So net energy cost.
Also, energy, the intensiveness of extracting the oils from the plant is extremely energy intensive, especially when it comes to algae and certain oils like the extraction.
Okay, I wanted to talk real quick about an apple seed reactor. I've helped quite a few people set these up. These are biodiesel reactors that you can build at home. I've met a lot of people. There's a tight-knit community here in Gainesville. They all know each other. Really neat. They actually build their own reactors in their garages. This picture that I have one of them, you have a hot water heater, and you put it through a mixer, and you can make biodiesel. You take the used vegetable oil from any of the restaurants in town. There's a lot of restaurants in town that will just donate the oil to you. One of the big companies that I really appreciate is Adams Rib Company up the street at 13. They give fuel to a local middle school and local high school for them to produce biodiesel fuel. So, and I really appreciate local businesses that do that. This is one of them that was pretty neat. You can find these on Craigslist. Very cheap apple seed reactors. Just hook it up, pretty simple, the instructions, tons and tons, countless of YouTube videos on how to do this. So, you don't have to be an expert at all, so it's pretty interesting. Okay, questions?
So how are you not going to be functional with water?
Well, what this does is you have to mix it. You put your sodium hydroxide, you put your methanol or ethanol, usually methanol in this case, and you put that through and then you circulate that, and then you make the biodiesel fuel, and what you do is you let the biodiesel settle out. And
I was just asking if you don't have to use a garage or anything. Not like, not these other systems.
No,
You're just using it for storage.
you need a pump to circulate, so that's what it is, and that's, you're just reusing stuff that is either thrown away or not.
Like old,
That's where 90% of the Appleseed reactor builders get their reactors from, is used ones that are being thrown out. Reuse it, you make biodiesel. So one other thing that I want to talk about is with the biodiesel reaction, you would mix your sodium hydroxide, methanol, keep circulating with a small pump. And then what you do is you put it in this tank and let it settle out. And what will happen is 20% of your reaction will drop out as this black liquid, and that's actually glycerin. So what you do is you can do a methanol recovery system, which you can watch videos on how to do that. And the methanol recovery system will work, recover some of your methanol, save you money. And also the glycerin that's used, you can make soap out of that. I was going to talk about short time. Yeah.
We're going to just a little bit out of it.
Okay, yeah, just got a second. One of the things that I've done over the past year is develop a soap product, taking the glycerin, filtering that, and producing a really cool soap project. And this was, I'll pass this around. Just be careful. I want everyone to take a look at this. This is it's made with a PLA plastic, which is polylactic acid plastic. It's kind of plastics that Christian Lunch uses, compostable plastic. It's made with glycerin, ethanol, and essential oils on campus. We did this as part of UF Biodiesel. I was a full volunteer, non-paid for over a year and a half. We would spend until 2 in the morning making these soaps, selling them to help support the UF Biodiesel project. And I just wanted to send those around real quick. And then this is Jatropha seeds, very cheap. They're less than a penny a seed. If you get in contact with me, or my contact information, you can get my contact info. I can give you one. So, yeah, these are Jatropha seeds right here.
How do you spell Jatropha?
Jatropha. It's Jatropha purpose. There's over 100 different types of Jatropha, but that's a specific one.
Do you know anything about the issues with it being an invasive species?
Yes, that was a big issue with, what was it, EP, and then, yeah. I went to Farm and Field Conference and someone mentioned it. It's kind of like up in the air. It's like an iffy gray area with Jatropha being an invasive species. Yesterday, for example, I went to Home Depot out on Tower Road and I bought 3 Jatropha plants. So that kind of tells me that I don't think it's invasive with Home Depot. So, yeah. Yeah. Well, I don't know. So it was kind of cool that I saw Jatropha being sold at Home Depot. So I'm going to grow it and see what happens. So I don't know if it's a hybrid seed or whatnot, but.
Do you take into consideration that, like when you have oil, that when you generate income for the people who mine the oil, process the oil, refine the oil, and transport the oil, that you get more circulation amongst agricultural things when it's not? Do you take in that economic effect, that there's more people involved with the growing of the crops or the biodiesels, the collecting of it, that you're employing more people, that it's a human energy and not a elitist, classicist machine energy where the wealth is focused into fewer and fewer hands?
Yeah, I see what you mean. That's taking into consideration the life cycle analysis and some of the plants. It's just the cost of producing the oil gets really high. I saw Southeast Biodiesel company that they employed over 200 people. They laid off everybody in the last 6 months because the price of soy just skyrocketed and there's nothing you can do. That's all oil speculation. Those are all speculators. You'll see, I believe one of the people at Farm and Field Conference came out with an iPhone app that shows you the oil speculation market and can show you how it's jumping around. And a biodiesel company cannot survive with oil prices going like this. When I first started biodiesel, soy was about $700. So you can see just with that fluctuation, it doesn't make sense. And these are plants producing 60,000, 100,000 gallons, 1 million gallons a year, so small price increases can really affect how they do their operations. But you're right, the biofuel industry employs a lot of people. So that's a good thing. I think, if we really get into algae and everything, more employment and stuff like that. So, good question. Yeah.
My question is regarding algae. They release their hydrogen.
Some algae is genetically modified it's not something I've really come across. Yeah. It's just,
That's another discussion again.
any more questions?
And I have a few questions. I'll try to keep it as limited as possible. What can we do to really support your cause for biodiesel? I mean, a lot of times people don't know how to convert their engines to biodiesel, or what would you say the future is? Or, well, I understand it's algae and other stuff, but as people in this room, what would you say to how can we help you guys out?
I think if you can spread the word and take what you've learned here, go on YouTube, watch as many biodiesel videos as you can, just research and know about it, read the Wikipedia biodiesel page. That was one of the first things I did, and I bought every single biodiesel book there. And I mean, you can do stuff like that, really immerse yourself. Understand everything about solar. If you're against nuclear, understand everything about nuclear, stuff like that. So, that's a big thing here. I'm gonna run through my other slides real quick. I know you have a lot of questions. It's awesome. I really appreciate it. The more knowledge you have, the better. So I'm just gonna run through my slides really quick, and then if you have questions, just write it down, and I'll try to accommodate everything and give my contact info. These are some pictures from the old biodiesel plant. What happened was, with funding issues, our biodiesel plant had to shut down. It was shut down officially as of March 15th of this year. We ran out of funding. We tried to put together a report for the vice president of UF. Unfortunately, with budget issues, I think a biodiesel plant wasn't feasible at that time. So I think it's still alive. He still really wants to build one, and we're going to go with grants. There's some work being done in Fraser Route installed by some of my former professors, trying to get a biodiesel plant back online, getting some grants. We're working on it. It's in the works. About maybe 70% of the way there, getting another reactor on campus. So it's happening. I'm letting them do the work this time. You can see right here, this is biodiesel with some glycerin settling out. I know how to build solar panels and solar thermal panels from scratch. Foil welding, everything like that. I love doing that. One of my former engineering partners, he worked in welding a solar thermal panel. What that does is provide boiling hot water. So we would have two solar thermal panels outside right here providing hot water to this tank, which was wrapped around our reactor. So we use the sun to power our reactor. We didn't have a heating coil.
What's the budget on that, Nick, creating your own solar panel?
I built this for under $100. So I'll say that. Sorry. Wait, questions?
There's lots of questions, and I know you're feeling a little pressure right now, but if we need an extra few minutes to answer all the questions adequately, talk to the next presenter, she's a little flexible, so we need a few extra minutes.
Normally, when I go to presentations, I have one or two questions.
This is totally different kind of crowd.
You guys are awesome. I really appreciate it. All right. So we had all the solar panels owned by University of Florida. We had over 52 solar PV panels. We equipped them up, and it was great. I worked with the American Solar Energy Society. I have a slide on them. I also worked with Society for Green Mobility. I had some people from the University on campus come out. I mean, we were like digging holes, we were doing stuff. This is an algae pond we restored. We were going to grow algae to make biodiesel. Funding crash happened. I don't know where we'd be right now, but this is great. We had this hooked up. We had so many people out there. None of us were paid. We were all volunteers. We did this for a year and a half, and it was great. We would spend our Saturday afternoon, ride our bikes out to the plant around 5 p.m. It was great. This was our mission. Our goal was to become a self-sustaining research facility, and we wanted to really bring forth a commercial application of alternative energy options. We wanted to develop an alternative energy curriculum. We wanted people to be aware. I had people show up at the plant some Saturday mornings and be like, I have no idea what biodiesel is. It sounds cool. You guys got solar panels. That looks cool, but I want to help out. What can I do? So, I'd run through the reactor, how to make biodiesel, stuff like that, how to hook up solar panels. It was great. It was first started by a graduate student named Doug Rank, and then I joined on over a year and a half ago. Doug Rank got graduated, wrote his thesis on biodiesel production, and then I kind of tried to take over. But unfortunately, the budget issue caused that to happen. So our long-term goal, actually, this was my favorite right here, was the cultivating algae right here. I think that was what I was really looking forward to, and some of the things I've done a lot of research on. I've grown my own algae, done a lot of experimentation on it. I also, Jenny wanted me to talk about some of the other alternative energy projects on campus. I'm involved with so many energy projects on campus. I try to budget my time between all these. I'm involved with Society of Green Mobility, Neutral Gators, American Solar Energy Society, and then many internship programs are across campus. I just really wanted to quickly run through those. This was American Solar Energy Society and Society of Green Mobility helping me take down some solar panels to move across the streets of biodiesel plant. This is on Southwest 23rd, by the way. Electric vehicle project with Society of Green Mobility. Like I mentioned before, because the biodiesel project kind of died, I was really like, what can I do? So I decided to form my own company. I formed two. And I'm sort of become an entrepreneur, and I have an idea that I want to really start a biodiesel company, so I did. The soap that you see going around is a result of the biodiesel project. A bunch of volunteers that helped me out are now my business partners. You know, they graduated, moved on, but they're still involved. We took the soap. I'm still getting phone calls about the soap, the glycerin soap, so you know, let's market it. What I've done now is I donate to the UF Foundation, and I donate money to 2 different clubs. I've bought the Pages go-kart and the solar panels for the Society of Green Mobility. They're trying to build an electric vehicle program, so I'm trying to help fund them for that and helping them out. This is a go-kart that they got. This was on the Rising Alternative Energy or Alternative Transportation Fair. They had a little go-kart there. So let's see. So one of the my last one actually. This is a Jatropha that I was growing in the energy park. I've become kind of an expert with Jatropha. I've read everything on it. I have tons and tons of seeds. I have over 1,000 seeds ready to go. And I've grown it. And so far the results have been pretty good. And I'm working with my company. My company is Grow Jatropha. I'm in talks with using landfills. Okay, this is my idea. I'm meeting with the Alachua County Solid Waste Coordinator very soon. I want to grow Jatropha on landfills, abandoned landfills that have been unused and everything like that. So that's what I'm trying to do. Jatropha is an amazing plant. I'll just give you details. It's grown in the desert. It doesn't need any kind of irrigation. You plant it, walk away, come back in a year, and you have wonderful seeds. They're the highest oil yield plant next to after. So I think it's a great thing. And then the glycerin soap. So those are kind of my two things that I budget my time between and kind of form. So, all right, okay. Questions? I think we have.
What were some of the major barriers starting a biodiesel project on a college campus in Azure?
Paperwork. I spent over a year just doing paperwork before we even make one drop of biodiesel. We had to do tax issues. Because we're a government entity, we had to go through all these tax issues, standard testing. We got to test our biodiesel. We had to get permitting for environmental health and safety. It's a nightmare when it comes to the paperwork, environmental health and safety, EPA standards, Department of Environmental Protection. I mean, safety is such a huge thing in biodiesel production. Safety is huge. I mean, you get kicked out of the plant if you're not wearing a hard hat or, earbuds or, safety goggles or something like that. I mean, safety is huge, and that was the biggest hurdle, I think, in making biodiesel. All right.
I think it's great that you're mentioning the plan to use abandoned landfill areas for growing Jatropha. Do you have any statistics or info about, I've heard that using corn and soy, especially for biodiesel production, ethanol production, has really raised food prices and a lot of
the Jatropha seeds that you're passing around, I want to warn you, are extremely toxic. Okay. That brings me up to a good point. Jatropha is toxic to animals, humans, bugs don't even eat it. Most fungus, microbes, anything like that do not attack the plant. The plant is perfect.
Why did you tell us?
Yeah, sorry.
That's really toxic.
Yeah. You get sick when you do, but anyways, that's what's amazing about Jatropha is you can plant it, animals leave it alone, there's no issues, it's not a food crop, and it also cultivates the soil. It actually helps out the soil a lot. There's a lot of papers on Jatropha. No one's really attempted to grow Jatropha on landfill before, so I'm doing a big study with it and trying to really research that, so.
The Jatropha is like, is there replenishing units in the land? Like, let's say that we have a piece of patch of land, will it actually improve like the quality of the soil?
Yes, yeah,
So,
there's a
like,
lot
it's
of
toxic,
studies.
so like,
It's, the seeds are toxic. The seeds are toxic. You're not really supposed to eat it. If you try to eat a few, you know, you'll start getting sick, so it's
so
not.
the idea is that's some replenishment of that wasteland?
Yeah, you know, the landfill's actually a really clean place. I just visited the reason we've been a tire tank is I visited the Polk County landfill all day yesterday, and they have like almost 100 acres of just, you know, green grass on top of the landfill, and then you have a very thick layer underneath a few feet, you know, and that's to keep out water from going into the landfill. It's to be perfect. So, yeah.
What's the quality of the biofuel that's made when you use the acid reactor?
You can get very, very good quality fuel. You do something also which increases the quality of fuel called water washing. You sprinkle water on the top and it'll pull out all of the unreacted components. So I think it's a great thing to have an Appleseed reactor. I've operated quite a few, a couple people set up quite a few.
You can use Appleseed reactor for the fuel.
Well, what happens is you have to get a screw press to get the seed. You put the seeds in and you get oil out, and then once you take that oil, you know, filter it. I've seen people filter it through a coffee filter before. You can do that, and then you take that and you make biodiesel with it. So yeah, you can actually do that. If you want to grow Jatropha in your backyard, a mini biofuel thing going. All right, Mandy, how much time do we have? 2 minutes. Okay.
I guess my question is there any push within the biofuel community to actually make some definitions or distinctions between different types of biofuel? Because, you know, there's the kind of waste to fuel and using recycled veg oil. I mean, we're seeing a huge push in Georgia, forest to fuel, which is very controversial. And I feel like there's this kind of big, biodiesel is good, it's something we need to be exploring, but there are a lot of aspects of the industry that are creating more environmental problems than they're helping. So for someone like you, who sounds like you're doing the research and really trying to find fuels that are sustainable, is there a push to try to re-clarify or do some kind of certification process or some kind of analysis of the industry so that the everyday consumer isn't buying like over-harvested, over-fertilized, trucked-in corn from Iowa to run in their car or vehicle? Like, is there a movement to kind of make that clarification or distinction?
There is, but that's extremely difficult to do. There would be some sort of government agency or something that could do that. If that would happen, that would be wonderful. I think that would really revitalize the industry and I think really change how things operate. And I completely agree with you. That's kind of why I'm doing all this research as part of my presentation, is taking into consideration that kind of point.
Is there like an indicator for us consumers? Like, do you just ask the producer what's your fuel source? Like, how do people make that clarification?
I think that's really difficult because you have to go and you have to actually see the biodiesel plant where it's getting the oil from and stuff like that.
I know there's still questions, but Eric, I will be sure to send out your information along with, you can write it here and have to take it down, but when I do the follow-up email and debrief stuff from the summit, I'll be sure that y'all have his contact information, and I assume you're happy to answer additional questions and talk to folks.
Yeah, definitely. I meet a lot of people for lunch and dinner and stuff like that that just randomly email me, hey, if you want to meet, you know, let's talk about biofuels.
And sorry for any questions that didn't get answered, but we are trying to stay on agenda, and we've been doing a really good job so far, so I want to continue that.
So just real quick, my email is eric.layton@ufbiodiesel.com. So that's my email. If you ever want to get in contact with me, you can find me through Facebook as well. Just feel free to contact me anytime. Okay, this is a biodiesel sample that I made, and this is one of the samples I made. So here we go. Turn it into it. Sorry, I got it. I'll pass the biodiesel sample. I made this at Green Hunter Biofuels, the largest biodiesel plant.
speaker because he knows a lot more about it than I do. And he kind of dipped out. Our next speaker is going to teach us a little bit about how we can get some money through grant writing. And